while we are learning tidbits of geometrical optics, one very important aspect of geometrical optics that comes your way in terms of problem solving, and I'm going to get you exposed to that aspect, which is about number of images formed when you have two mirrors inclined at a certain angle with each other, right? We'll start with a situation where the two mirrors, the two plane mirrors, by the way, M1 and M2 are mutually perpendicular. We'll start with a situation where M1 and M2 are two perpendicular mirrors, right? Angle between them is 90 degrees, and say this is the point where they intersect, P is the point where they intersect, and we have a point object O. We have a point object O, which is, let's say, at a distance x from mirror M1 and at a distance y from mirror M2. And what we want to be able to do is we want to find the number of images in this case. Now this is a very simple situation. First things first. Look, if O is the object at a distance x from M1, then because of M1, its image would be O1. O1 is the image of O as formed by M1. Object distance is image distance. Yes or no? Right? So that's one image. That's one image. That's formed purely by M1. Now, obviously there would be rays of light from O that would be incident on M2, and there is going to be an image O2 of the object O formed by the mirror M2, and then again if this distance is y, this distance will also be y. Object distance is image distance, right? So two images for sure, O1 and O2. Now realize that rays of light that start from O and get reflected by the mirror M1, say there could have been a ray that could have been, say, something like this, for example, right? This could have been an incident ray and this could have been a reflected ray, right? And that means, you know, this reflected ray will become an incident ray for M2, and this will become like a virtual object for M2. This will become like a virtual object for M2. So then, for M2, realize that O1 is an object and its image formed by M2 is going to be O21. O21 is the image formed by M2 because of O1 acting as a virtual object. So O1 acts as a virtual object for M2, and its image is O21, right? So O1 acts as a virtual object for reflection by M2, and then its image is formed O21, and obviously, you know, this is my object distance. Of course, this is a virtual object then, this is a virtual object, and its image would be O21, which would be this point. Very clearly, if this is y, this is going to be y2. And of course, if this is x, this is also going to be x. So there is a third image. There is a third image, which is reflection from M1 and then reflection from M2, right? Also, realize that rays of light that first get reflected from M2, start from O, first get reflected from M2, would seem like passing through O2, and that this O2 will act as a virtual object for M1. O2 will act as a virtual object for M1. So if O2 is a virtual object for M1, there is going to be an image of O2 formed by M1. So O2, object distance, as far as mirror M1 is concerned, this is the object distance, and this would be its image distance. And this image is going to be O12. That means these two images, as you can see, coincide with each other and eventually would stagnate into one image. So how many distinct images? One from O1 alone, two from O2 alone, and two other images that coincide. So effectively, three distinct images formed out of two perpendicular mirrors placed this way. How about it, right? So there is also a situation which could be, you know, I could have had a mirror like this, and say could have had an object O here, and this could have been a mirror. Say if this is a mirror M1 and this is a mirror M2, and this object is placed here, you know, this is perpendicular to this edge, right? Very clearly now there would only be two images. There would be an image of O formed by M1, which is O1, image of O formed by M2, which is O2. Why? Why so? Because realize that if a ray of light starts from O and is incident on M1, then subsequent to reflection from M1, it'll never reach M2. So then M1 forms only one image, which is O1, right? Similarly, if there is a ray of light that starts from O and is incident on M2 and it gets reflected, then it's never going to reach M1 again. So then its image is going to be O2. So there would be essentially two images, O1 and O2 in this case, if there was a situation like this. Perpendicular but truncated perpendicular mirrors and O placed at the intersection of the edges. This is how it's placed. Yes or no? So what I have discussed right now is that if there were two perpendicular mirrors actually intersecting at a point P and there is an object O, then there would be three distinct images. There were actually four images, of which two were coincident images and there were two other images. So essentially three distinct images can be formed by two perpendicular mirrors, and you must remember this result. Now what I'm going to do is I'm going to migrate into a more general case where the mirrors are not perpendicular, they are inclined at a certain angle theta with each other. How many images would then be formed? That would be my next subject of discussion. Thank you so much. Bye.